Hello everyone. We've been learning about trigonometric ratios in our past few videos. We have seen that these ratios are the same for right triangles. Of course, trigonometric ratios are applicable to right triangles. So let's consider a right triangle here. So this is one right triangle, and let me also draw another triangle, right angle triangle, which is slightly bigger in size. By bigger I mean the lengths of the three sides are larger, are longer in the second triangle. So the first triangle is right angled here, and the second one is right angled at this place. And let's consider that the second angle, this angle is A, or let me say it's 30 degrees. Let this be equal to 30 degrees, and this triangle also, let it be equal to 30 degrees. So these two triangles are similar, meaning two corresponding two angles are equal. Two of the corresponding angles are equal, so they are similar. So what we have seen so far is that the trigonometric ratios of this 30-degree angle is the same for both the triangles. That is, sine 30 degrees for the small triangle is the length of the opposite by the length of the hypotenuse of the small triangle. And for the big triangle, the sine 30 degrees is equal to the length of its opposite, and the length of its hypotenuse. But both the sine 30 degrees is equal to are the same for both these triangles. This is what we have been studying so far, right? But now in this video we are going to arrive at the values of some of the specific angles like 0, 30, 45, 60, 90, etc. It becomes very handy when you have these values with you. So let's try to arrive at some specific angles. For that matter, we'll have to consider one right angle triangle. So let me draw a big one. Yeah, this is a right angle triangle, and let's assume that this of course is 90 degrees and the other two, let it be equal to 45 each. So this angle and this angle, let it be equal to 45 degree each. It looks like an isosceles triangle also. Now the sum of the angles of any triangle is equal to 180 degrees, isn't it? Now let me try to reduce one of these angles. What will happen? So this one angle is always 90 degrees. This remains fixed. It's always 90 degrees. We're not going to change it. Now we are going to change these two angles, and we are going to reduce one of them. And while reducing one of the angles, automatically the other angle is going to increase. So let's try doing that and see what happens. So I'm just changing the shape of the triangle by pulling it, and at the same time I'm trying to reduce this angle. So this angle, it was 45 initially, but now it is slowly reducing, and as this reduces, the second angle becomes larger. So while let's reduce again. So see, this angle is reducing, the other angle is becoming bigger and bigger. So how much bigger will it become? So reducing, see, it is reducing continuously. So now maybe this angle which we are trying to reduce is equal to say 10 degrees. So what will this angle be equal to? It will be equal to 80 degrees, because one of the angles being a right angle, the other two has to be equal to 90 degrees. One angle is the complement of the other angle. They would add up to 90 degrees. So when this angle, the angle which I am marking in white is 10 degrees, the angle which I am marking in red would tend towards 80. When this tends, the white one tends towards 10 degrees, this would become towards 80 degrees. So now what I am going to do is I am going to reduce the white angle to totally 0 degrees. What will happen to the red angle? It will become 90 degrees. Why am I doing this? We are going to find the sine of 0 degrees and the sine of 90 degrees. What is sine of 0 degrees? It is the opposite and hypotenuse. The length of the opposite divided by the length of the hypotenuse. This ratio gives sine of 0 degrees. And what is sine of 90 degrees? The length of the opposite of 90-degree angle. I'll write that in blue. The length of the opposite of the 90-degree angle and the length of the hypotenuse. The hypotenuse is the same for both the angles because both are actually in the same triangle. So this is going to be the hypotenuse for both the angles. But what about the opposite for both the angles? For the white angle, which we are going to make to 0, this would be the opposite. I'll write the white angle's opposite in white. Yeah, the white angle's opposite side, I have written it in white. This is the opposite. And what about the red angle's opposite? I'll write it in red. For the red angle, this would be the opposite side, isn't it? So let us see what happens to the opposite sides for these two angles. So as I am reducing and as I am making the white angle to 0 degrees, the red angle becomes equal to 90 degrees. So I have reduced totally now, and the triangle has collapsed into a straight line. It's collapsing into a straight line. So what happened to the opposite of the 0 degree angle? The opposite of the 0 degree angle has vanished totally. So we see that the length of the opposite is equal to 0. For sine 0 degree, the length of the opposite is equal to 0. And we are not concerned about the length of the hypotenuse now. We do not have to measure it because 0 divided by any length is equal to 0. So we have arrived at sine 0 is equal to 0 degree. Now look at the 90 degree angle, the one which became the 90 degree angle. What happens to its opposite? What happened to the opposite of the 90 degree angle? The opposite has coincided with the hypotenuse, isn't it? For the 90 degree angle, the opposite has totally coincided with the hypotenuse. See? Now look at the red angle, which is 90 degree, which is becoming 90. Now it is 80 degree. Now if I make it to 90 degree, and now look at this side, because this is the opposite side now. This is the opposite side for the red angle. The blue arrow mark is the opposite side for the red angle. So what is going to happen to that 90 degrees? So once again, moving the triangle, making it collapse into a straight line, and at the same time making the red angle as a 90 degree. See, it's become almost 90. Now it is 90. It's become a straight line. But what happened to this opposite side? The opposite side has coincided. The opposite side has totally coincided with the hypotenuse, or the length of the opposite. The length of the opposite is equal to the hypotenuse. Or if I say the opposite is sum, the length is some k, the hypotenuse is also the same k. So the numerator and the denominator get divided because they both are k. The factor becomes equal to the fraction. The fraction of this fraction, the opposite by hypotenuse, becomes equal to 1. K by k, opposite by hypotenuse, both being equal, it becomes equal to 1. So with this same triangle, we have arrived at both sine 0 and sine 90. Sine 0 is 0 degrees, whereas sine 90 is equal to 1. I hope you understood what we were trying to do with this figure over here. We were just in any triangle, I'll draw it for you. In any triangle, this is 90 degrees, and we were just trying to make this angle become 0 degree and this angle become 90 degree, and we found the trigonometric ratio, the value for the trigonometric ratios of sine 0 and sine 90. I hope you followed it. I suggest that you watch the video once again in order to get perfect clarity. Now we have arrived at sine 0 equal to 0 and sine 90 equal to 1. The same way, we will also try to find the values of the ratio cos 0 and cos 90 in our next video. Thank you.